Right, I make that time, everyone. If everyone looks good now. People still streaming in. So welcome to Continuous Delivery Patterns for Contemporary Architectures. My plan over the next 50 minutes is to share some of my successes, or some of my team's successes, I should say, and also some of the failures I've had over the last few years doing continuous delivery with what I'm calling contemporary architectures, but that ranges everything from monolith, SOA, self-contained systems, microservices, serverless, call it what you will. Lots of buzzwords. I'll try and minimize the buzzwords if possible. I'll start by saying we're definitely having lots of promises made at the moment around architecture, aren't we? Lots of excitement around sort of microservices, around the platforms that are supporting them. But I think there's some drift between the expectations and reality sometimes. Now, it all looks so good, doesn't it? Just take your architecture, hack it up, put it into containers, ship it, we are done. This is kind of what we're being sold a little bit. And I'm guilty of doing it sometimes as well. Many of us are dealing with legacy systems, or money-making systems, as I like to call them. But many of us are dealing with complex legacy systems, a whole bunch of other stuff going on. Often what we're putting inside the container, what we're hacking up, is a bit of a tire fire, yeah? Let's be honest. We've all written tire fires, yeah? Problem is, when you put tire fires in a container, what you actually get is literally tire fire in a container. And you'll notice the firefighters there. This is what our industry is now calling DevOps, yeah? This is the kind of, I make a lot of money off this, it's all good, yeah? But I say it in part jest, but it's a bit of a problem, to be honest. It's a bit of a challenge, yeah? And we as architects, I'm assuming most of us in the room are developers, QA, architects, technical leaders. You're all a leader. In fact, you're at a conference. You're a kind of self-selecting group. You're keen to learn more. You're keen to share. You are leaders. So it's our job to kind of stop some of this stuff happening. And I'm not saying DevOps is bad. DevOps is awesome. Don't get me wrong, but we need to think at an architectural level, and I think continuous delivery has got a lot of value here. I always like to start my talks by concluding them, but also by sharing some of my sort of theses, what I'd like you to take away. And I think we as architects, we as developers, we as QA engineers, we're moving from building complicated systems to complex systems. And I'll work on the terminology a bit more later. Architecture is becoming more and more about technical leadership in my mind. And I'm standing on the shoulders of giants here. People like Pat Kowar, Simon Brown have been talking about this for many years. And I'm basically standing on their shoulders. They've done some fantastic work. I think, in the pitch today is we're going to be encoding these requirements. We as, architects, as technical leaders, what we're learning in terms of functional and non-functional requirements, we're going to be encoding it into a continuous delivery pipeline. Now, a word of warning, this talk is more conceptual based, okay? I've got a book, I'll put the next slide up. This is me, love getting involved on the Twitters, at Daniel Bryant UK, work as a tech consultant and a CTO at a small startup company based around testing microservices and products and open source around that. I've got some books. I'm actually doing a book signing later on tonight with the one on the left there. That's a little mini book. So that goes into many more technical details, hopefully, in terms of code and all these things. My main craft is Java development, do a bit of Go, a bit of JavaScript as well. But this talk is going to be more looking at the concepts around architecture and continuous delivery, not so much of the code. I'm happy if people aren't cool with that and want to walk out, that's totally cool. But just sort of setting expectations. So setting the scene, we as architects, we as technical leaders, you don't have to be an architect and technical leader, we are often the kind of the go-between between business and the people in the trenches doing the work. And often we should be working very closely with the business. We should be working in the trenches too as architects. It is my strong belief that all architects should code. I'll put that out there now. Technology moves too fast for you not to develop empathy with it by actually using it. So I think if you're an architect, a technical leader, you must code. But we do work very closely with the business. And this is Adrian Cockcroft's work from a couple of years ago. He said the business, key business drivers these days are velocity and stability. Yeah? And it's all about, for us as technical leaders, aligning IT with the business, developing things faster, and trying not to mess up. Yeah? And we unfortunately are seeing some of these things already in the industry now. I'm sure people have bumped into Equifax over the last couple of weeks. And it's easy to pick on Equifax, but there is many other companies in a similar situation. We need to think about these things. And for me, continuous delivery plays a big part in this. Agile Steve Smith, fellow Londoner, great guy, is writing some awesome books measuring continuous delivery. He says continuous delivery is achieved when stability and speed can satisfy business demand. Speed and stability can satisfy business demand. This is key. I've worked in a few organizations where they're trying to make awesome new pipelines, and in reality, they satisfied this. The business was actually the slowest point in there. It was the bottleneck effectively. So if you're actually matching the stability and speed that your business needs, job done. Yeah, you can work on refactoring the app. You can look ahead at new technologies, but fundamentally, this is kind of when you know you've got continuous delivery working within your org. As a consultant, I see a lot of orgs that aren't working too well with continuous delivery. It's kind of a little bit biased there because I get called in when things are going wrong. But I see a lot of this, discontinuous delivery, when stability and speed are insufficient for the business needs. And it's our job as technical leaders to kind of nudge the continuous delivery in the right way. So let's have a little look. I started my career early 2000s, but I caught some of the tailwind of the 1990s, and it was very much around monoliths then, sort of single language. We optimized for stability, and there were specialists. I was a Perl programmer. I was a sysadmin, these kind of things. I entered the industry. I was building a lot of monoliths, both in Java and also Ruby on Rails. It was very much the decade of the monolith. I love monoliths. Ruby on Rails was awesome in many projects I worked on for getting product market fit. We could code crazy fast, meet business demand. Sometimes we bumped into architectural issues later on, but that's what it is. We saw the rise of cloud computing, kind of colo and private data centers, and we saw the emergence of full stack. I did JavaScript, I did Java. I was a full stack developer. We also saw the emergence of DevOps, these kind of things as well. And then as we moved into 2010s, where we're at now, it's all changed once again. It's microservices, functions, SaaS, all the things. And polyglot languages, I think that dream isn't working out quite as well as we perhaps wanted, but it's interesting nonetheless. Everything is online, everything is networked, cloud, containers, software-defined everything, and we're optimizing typically for innovation, or at least in a lot of places we're optimizing for innovation. And we're seeing new teams emerging around that, like FinDev, site reliability engineering, and platform teams. Now, as we've kind of moved through this, I think abusing the Cynefin model a little bit, but if anyone's seen the Cynefin model, it talks about sort of complexity and so forth, and how we identify things and how we deal with complexity. I think to some degree in the 1990s, it was a relatively simple era. And I don't mean simple as in easy. They're two very different things. It was certainly not easy to build systems back then, but it was relatively simple in terms of the components involved. It got complicated in the 2000s, a lot more things going on. And moving around the Cynefin model, now we are in a complex system. We are typically now building complex adaptive systems. We are building distributed systems, microservices, serverless. We're gradually recognizing that as an industry. It's certainly, when I started working on microservices 5 years ago or so, it became painfully obvious we were dealing with a distributed system. We are heading towards the kind of chaotic region, I think, in the Cynefin model. Nothing wrong with that per se, but we've got to recognize where we're at. Yeah? But at the moment, we're very much here. And accordingly, we need to look at sort of continuous delivery pipelines to make the most of where we're at and to build sort of successful delivery mechanisms for our business ideas, for our code. Don't worry, this is a typical build pipeline. It's a Java-flavored build pipeline. Don't worry about the details if you can't read the text. I'll kind of walk through it in a second, and the book goes into more details. But fundamentally, when I'm doing development, I write code on my laptop. I work closely with the business. I get requirements, push it to GitHub. Then some kind of CI, like Travis or Circle CI or Jenkins picks it up, builds an artifact, may do some code quality, push it down through to QA, we do some testing, maybe we use mocks and stubs for third-party integrations. If it's all good, we then push it through to staging, we use more realistic environments, sandbox environments, say. Ultimately, we push it through to prod if it's good to go. If at any point my new bit of code fails along the way, we go back to the start and we start again. A key thing I want to mention is that continuous delivery does not end with deploying something into production. Yeah? It ends when my component is retired. Yeah? The missing part in this diagram, and many others have seen as well, is there's a loop. We should observe what's going on in production. We should take metrics. We should monitor what's going on, and we should close the loop. We learn from our business observability, our business metrics. We learn from architectural metrics, and we learn from operational metrics, and we make improvements. And thus, the cycle begins. Yeah? Now, I'm going to introduce on the next slide, if you're doing things like Docker and containers, it changes the build pipeline a little bit. Again, I've got some stuff online. You can read about the details if you want. But the main point I want to say is, if we're now going to serverless, going to microservices, The challenge we've often got is how do we deploy them all into production? Do we kind of have some notion of funneling? We've got multiple pipelines, building our services, putting it into Docker containers. Do we then kind of gate a release here and say, this is V1 of our system, with V1 of this microservice, V2 of this, V3? I've seen plenty of these things. It does work sometimes. It can be quite effective. Or do we want individual pipelines with the ability to push into production at any given moment? Yeah? This thing goes into production completely separately from this, completely separately from this. If we want this, and it is kind of the holy grail, being able to go super fast, business units working on functionality, pushing it into production, we need to guarantee the interaction between dependent services is good. Yeah? And that's a big part of continuous delivery when you're working with microservices and serverless, I think. Are the interactions good? So taking it a step back, that's kind of the, setting the scene of where we're going in this talk. We've actually, a lot of us have been working on monoliths for quite some time. Even if it's kind of SOA, often it's kind of monolithic concepts. And the monolith is so kind of simple, isn't it? It's all good. But we break it down, and I'm going to reference some stuff from the Self-Contained Services website, but there's always domains in a monolith, yeah? There's always some form of layering, be it API, UI, biz, service, level, repo, DAOs, all different names for them. And there's typically modules, components, frameworks, and libraries within our monolith, yeah? And that kind of, that's it, yeah? And we should and we can build very well-designed monoliths. Simon Brown often talks about this stuff, and he says if you can't build a well-structured monolith, what makes you think microservices are the answer? That's a mic drop moment in my mind. But I've certainly built my fair share of kind of scrappy monoliths, so I can't really talk too much. But we're going now towards more things like self-contained systems. Self-contained systems, if you hadn't heard of them, the InnoQ team talk a lot about them. And it's kind of microservices, but you have full end-to-end responsibility. You have a UI, typically, and you have a data store underneath. Really well worth a read if you haven't heard too much about them. Microservices we're all hearing about, they don't have necessarily the full kind of domain piece to them. You can have different services, like I know MuleSoft talk a lot about process services, process microservices, service layer or composition services. You can kind of have microservices being composed to deliver a key piece of functionality, whereas self-contained systems, they typically work pretty much in isolation with the bigger business goals in mind. And now, of course, we're seeing function as a service, FaaS, the most horribly named kind of thing ever, serverless. Clearly, there's servers involved. We all know that. But serverless is kind of stuck. So we're often looking to either migrate monoliths to these kind of things, and SOA as well, or we're looking to build a greenfield system with these kind of things in mind. So this is a brain dump slide. I apologize, but I'll walk through a few bits of it in a minute. And what I'm trying to say is these are the kind of things I work with on the top. Monoliths, SOA, microservices, self-contained systems, FaaS, serverless. And kind of I've tried to pull out some interesting things that I think affect us as architects and us as people developing continuous delivery pipelines as well. Now, it's changed. With monoliths, it's typically one team working on things, and you're working typically on a monolithic deployment. Etsy, Stack Overflow, they're all powered by monoliths, and they've done kind of continuous delivery and DevOps really well. So they can push, Etsy and Stack Overflow can push about 50 times a day or some crazy number. They've done this really well. And the point I want to make is if you get continuous delivery working here, it's good, and it doesn't change too much as you add more and more functionality, because you're just working on the monolith. As we work down through the stack and say look at something like SOA, and SOA kind of shares a fair bit with monoliths in that it's monolithic orchestration of multiple services. Typically there's some kind of centralized control plane, some kind of governance plane, and typically implemented by ESBs, enterprise service buses, or heavyweight MQ technology. But again, if you get your pipeline working for your service, you're kind of good. And many enterprise systems I've worked on, that you can count the number of services. The wider enterprise has probably got hundreds, but your local domain, you can understand and comprehend the services involved. So if you get 10 pipelines working, you're kind of good to go. Microservices changes the game once again. Yeah, we're building distributed systems. We're looking to deploy our services individually, and we're pulling the communication smarts away from the platform back into our components, yeah. The whole, is it like dumb pipes and smart endpoints that Neil Ford talks a lot about, and I think is really nice. But it means now, when we're building continuous delivery, we have to think more about the interactions between services. Yeah. And finally, hands up, I've not done lots of serverless, to be honest, but I've done enough to kind of realize a few issues, and I'm really quite interested in this space, and a lot of, as people are, as the kind of next thing we're looking at. But this is different again. It's event-driven, it's asynchronous. The way you orchestrate serverless systems is still kind of being fleshed out as we speak. It's largely vendor-driven at the moment. There are some serverless frameworks popping up now. Amazon are doing a fantastic job. Google, Azure are doing a fantastic job. And therefore, we often need to put their frameworks into our continuous delivery pipeline, which can be challenging at times. Take a pause for a second. So we've looked at some of the pipeline stuff. We looked at some of the architectures there. But I can't come to a software architecture conference and not mention fundamentals. Because this, as I'm getting a bit older and maybe wiser, I'm realizing that a lot of stuff I see is it's been there before, and I need to remind myself of how it relates to fundamentals. And coupling is just, components have little or no knowledge of other components. And when you're building microservices, this is fractal. Your classes should have no knowledge of each other, your services should have no knowledge of each other, and your applications should have. This kind of turtles all the way down, if you want to say that. Cohesion, it's the degree to which elements belong together, and these kind of things, and things like single responsibility principle, separation of concerns. But this stuff is highly, highly impactful in the way we build systems, regardless of the architecture, and it really impacts continuous delivery as well. Yeah. Now, going through some of these things, I find if a system is cohesive and it's loosely coupled, it's much easier to reason about when I'm designing it. I know where functionality should belong, and I know when I change something or my team and I work on a new design, the impact is going to be minimal because it's a loosely coupled system. Building and testing, cohesion limits dependencies. I've worked on some Spring systems, and I love Spring, but it's easy to poke fun at Spring, a Java framework, where just to boot up a unit test, I had to inject 20 dependencies into this class because it was a very incohesive class, or a class with low cohesion, I should say. So we had to put 20 mocks in just to get the class stood up for a unit test. So in loose coupling also, if you've defined your API well, it allows good mocking. So you want to promote mocking and service virtualization, but you want to minimize the number of dependencies needed to get things rolling. End-to-end tests, same kind of deal. Cohesive systems that are loosely coupled are generally easier to orchestrate for end-to-end testing. I've worked on a few systems where we had to kind of take a snapshot of the whole world, put it into the database, and then start our tests. Whereas a cohesive system that's loosely coupled, you can take mini snapshots, and you can do combinations and permutations. Deployment, same kind of thing, minimizes the number of components in play if it's cohesive. And if you have a coupled system where you need to deploy lots of services in one go, you kind of got a distributed monolith there, to be honest, yeah? Not necessarily bad, but you're often paying like microservice tax in terms of going over the wire for comms, and you're not getting the benefits of independent deployability. So worth thinking about. Observability, very similar to design. Cohesive systems are easier to understand. Shout out to Charity Majors, Mipsy Tipsy on Twitter. She's doing a lot of awesome stuff around this. She's building a company around this stuff. She worked at Facebook on their Scuba system, and she's got a lot of articles that go into much more detail than I'm going to talk about today. But observability is critical, and having a cohesive system and one that's loosely coupled is generally good. High coupling leads to a large blast area when something goes wrong and you're trying to observe what's going on, and it leads to what I like to refer to as murder mystery debugging. And much as I'm a fan of kind of all these murder mysteries, I don't like it in production. Yeah, it's not so good. So a journey of 1,000 miles, as they say, begins with a single step, yeah? And I'm going to walk through now sort of a few ideas of how to build a pipeline. The first, it's often really important to get kind of set up working locally in the right way to set the tone for the rest of the system. So I'm a big fan of using things like Docker and Vagrant. If I'm working on a microservice system, or my team and I are working on microservice systems, I like to package things in Docker or Vagrant because it avoids Snowflake development machines where works on my machine, all that kind of classic stuff. And also, if I'm working on one service and I need to interact with another service, if I package it in something that's kind of hermetically sealed, I can't cheat by sneaking in and changing stuff. Yeah? Or if I do want to change stuff, I have to work with the team that owns that service. So if I deploy sort of immutable Docker images, and I'm testing locally, I'm building my service against the Docker image, it's less tempting to cheat than if I'm spinning up two versions of this, two independent versions of the services where I have access to the code of both. If you're working on serverless stuff, things like SAM Local are really cool. It's from Amazon, an open source tool. You can basically spin up now. It uses Docker actually under the hood. You can spin up as if you were running your function on Lambda, on Amazon, on the cloud, but you can run it locally in Docker. So when I'm on the plane, I can hack away with this. It's quite funky, actually. Taking it one step further, I do see some people that say, there's a classic Hacker News article that said, if you cannot spin up your entire system on your laptop, you are not doing microservices. Yeah. And I was like, this person has clearly never worked with a system of any scale, because I cannot run half the systems I work on my laptop. Partly because a lot of stuff is Java, and the JVM is quite memory hungry, but also I've got a lot of legacy systems, a lot of vintage money-making systems involved that simply can't be run that well on the laptop. So I read about this in an article. My team and I are working with an awesome company in the UK called Not on the High Street. If you haven't heard of them, check them out. They do awesome Christmas gifts with Christmas coming up. They're amazing. They do personalized stuff. But we were basically helping them move from their monolithic Ruby on Rails app to a microservices type thing with Ruby and Java and Go and some other stuff as well. We bumped into a whole bunch of problems developing locally. And we started cheating, and we noticed that cheating working locally was spinning up multiple things. We kind of lost our cohesion sometimes. We increased coupling inadvertently. Some open source tools have popped up around some of the patterns we identified. I just want to share them because I always get asked about these at the end of the talk. First one is by a company called DataWire, and they've got some awesome tools. One in particular called Telepresence allows you to connect with a remote Kubernetes cluster. So it is Kubernetes specific, but you can spin up all your things in a big Kubernetes cluster in the cloud. I talked about that as a pattern, kind of QA environment on demand, and I can develop locally on one service, but I can use Telepresence. You can see the Blackbird with his VR there. I can code locally, but it's like I'm coding in the cluster. So I can use my one service, but Telepresence basically maps out all the comms via proxy to the Kubernetes cluster. I can look at the mount points in Kubernetes. I can look at the shared volumes and all these kind of things. I can look at the environment variables. It's just a nice way to be virtually somewhere else. Really nice tool, open source, written in Python. Check it out. Also, shameless plug for a company I'm working with now, Specto, but we're using, and there's many other tools in this space. This is an open source tool called Hoverfly, but there's also Mountebank and Wiremock, which are really nice tools. But the core premise is you don't run all the services locally, you run virtual services. So you basically do some kind of request and response, and you can use Hoverfly to record that, and then Hoverfly can act as a kind of virtual service. And because Hoverfly is a Go binary, very lightweight binary, I can spin up 20 services on my local machine or in the pipeline, and I can develop against them as if I'm using the real service. But the point I want to make is these two patterns, having something remote and then proxying into it, and having something like service virtualization, is a nice way to develop locally without cheating, without spinning up lots of things on your local machine. So testing next. So I'm not going to spend too much time talking about core concepts, but totally worth reading if you haven't read about these things. Are people in general familiar with the testing pyramid? See a few nods. Testing pyramid, worth checking out. And the agile test quadrants, people, Lisa Crispin's work and Janet, I've forgotten Janet's surname now, but there's an agile testing book and more agile testing book, which is amazing. But I'm not going to talk about these things too much, but if you haven't bumped into them and you're trying to put testing into your pipeline, trying to automate testing, these are your go-to references. Similarly, I'm going to stand on the shoulder of giants. I'm going to talk about something different in a minute. But Toby Clemson wrote a fantastic article on Martin Fowler's blog. All the good stuff's on Martin Fowler's blog, yeah. I so want to get on Martin Fowler's blog. It'd be awesome. But it's an amazing article. And Toby has done a fantastic job. It's a slide deck. And he breaks down how to test microservices, how to isolate different parts of the microservice, what techniques to use. This is my go-to reference. I've not done anything similar because it's just so good, and there's no point, basically. It's a really good article. So these are kind of fundamentals. I'm not going to assume knowledge in the talk of them, but if you are going to look at automated testing in a pipeline, there are your go-to references. I'm going to talk a little bit about sort of end-to-end testing, functional end-to-end testing. It gets a bad rep a little bit, end-to-end testing, with good reason sometimes. I think a lot of us, developers, architects, and the business sometimes see end-to-end testing, and I'm talking about things like behavior-driven design, Cucumber, all that kind of thing. We see it as scaffolding. But unfortunately, the scaffolding never comes down, yeah? And it obscures our building, ultimately. And any change we make to the building, the scaffolding has to be rejigged. And this is, if you ever worked on a big system, it's kind of the opposite, actually, of this. You get the ice cream cone, where you have lots of end-to-end tests and very little unit tests. But if you ever worked on a system like that, the slightest change in your code ripples through the application, and you have to rewrite a lot of tests. So what I think is treat end-to-end tests more like a contract, yeah? And again, this applies, not only at the application layer, the system layer, but the service layer as well, the microservice layer. It's kind of fractal again. And when I say contract, what I mean is if you're doing a building contract, you specify exactly what it should do. And I think in the software world, exactly what you should do should be limited happy path tests. Yeah, my application, if it's an e-commerce application, I can browse for products, I can put the products in the basket, and I can check out. If I cannot do any of those three things, I am losing money as a business. Yeah. So those are my kind of critical happy paths. But then I do happy path tests on the individual services involved as well. It allows you to build things outside in, and I found this really beneficial, not only just in terms of building applications and services, but even building things like classes. Some people refer to this in the test-driven development space as the London School of Mocking, London School of TDD. But I'm a big fan of using things like Serenity and Cucumber to basically work alongside the business, using something like Three Amigos, where me as a developer, a QA person, and a business person, we work together, we define the kind of core functionality, the happy path. Bonus if we can encode it in something like Cucumber, or something that we can run in our pipeline as well. And that then becomes our contract to functionality. And again, if you're building services that are reasonably granular, if you've got this contract working right on the service layer, you can, in theory, throw away the service and rebuild. Yeah? And I've seen a few companies do that. We had a Java service that was memory issues. So with the contract, we rebuilt it in Go. It was a relatively simple service, I would say. But again, it was a proof of once you have the contract specified right, it kind of becomes your interface. Yeah? So the key thing I want to, it's only a bit of a high-level tour here, but don't think of end-to-end testing as scaffolding. And the business often loves end-to-end testing because they understand it, particularly non-technical business stakeholders. And we should definitely, as technical leaders, as architects, we need to work with the business to increase that kind of understanding. But the end-to-end tests can become a crutch, yeah, and they can slow our continuous delivery pipeline down. Think of it more as a contract, happy path contracts. And the bonus is if you get the BDD kind of stuff working right for your tests, you can actually run it in production as a synthetic test. So you continually, or semantic monitoring, there's a whole bunch of different names, but you continually run those happy path tests against production. And if I can't browse for a product, check out, or add something to a basket, big red alarm should go off and we should perhaps roll back or fix forward. But if you get the contract thing right, you can reuse your definitions, your assertions, in many different places. Talking of contracts, we looked early on at this kind of choice between do I gate things, do I funnel it into a batch of microservices going out that we know all work well together, or do we kind of have some notion of contracts where we can guarantee interactions as the system evolves? Yeah. Now, have people heard of consumer-driven contracts? Kind of definitely, yeah, awesome. If people have, definitely in vogue. And I like it. Basically, it says APIs are service contracts, and there's a thing called consumer-driven contracts. Again, Martin Fowler's blog. It's all good. See where I spend a lot of my time reading. But the client basically can define what they need, and you can encode it, say, in a JSON schema. And this client might want something different to this client, something different to this client. But ultimately, they can run within their continuous delivery pipelines. Is the producer offering a contract that I need? And if the producer changes something, they are also running in their pipeline these contracts, and they can spot if they are making a breaking change. Yeah, very powerful kind of stuff, and it gives you that interaction guarantee at a syntax level between services. Not necessarily semantics, but at a syntax level. Check out Martin Fowler's awesome article there, talks more about it. If you're looking for tech, I've done it not on the high street. We actually use something called Pact. Pact is a language agnostic framework where you define schema in JSON, and it's Ruby, Go, Java, JavaScript, and a bunch of other things. If you're in the Java stack, you can use Spring, which is a very nice way of doing consumer-driven contracts. Put them in your build pipeline. They can basically be run all the time, and you locally can see if you're breaking contracts, and critically, you can see in the pipeline if you're breaking a contract in a backwards incompatible way. Now, people often forget about messages as well, yeah? And basically, what about messaging, yeah? Well, message schema are an API. If you're using AMQP, Rabbit, Kafka, fundamentally, if I've defined 4 fields in my message, that is a schema, yeah? And I take my cues from Gwen Shapira. Gwen, I think, is a committer, on Apache Kafka. We obviously heard about Kafka this morning, which is great. And she did a fantastic talk at KubeCon New York recently that talks about, obviously Kafka themed, because Gwen works at Confluent, but she talks about contracts and compatibility. So I'm not going to talk much about it, other than to say, check out Gwen's talk. It is really interesting, very important if you are using message-driven systems. You can do a lot of what Gwen is talking about if you're using things like Rabbit by using protobufs or Avro or something. So you use Rabbit as the transport mechanism, but you define your service-to-service interactions using a more strict interface definition language. Something like Google protobufs. You can define effectively the message payload, and you can have Rabbit send that, and you can do assertions in your build pipeline. Are we changing the protobuf file, for example? But Gwen, it's a great talk to give you sort of your foundations. And the reason Gwen was talking about it is Confluent have got this open source schema registry, Java flavored, I'm afraid. It's, as far as I know, Maven plugin there. But you can basically, very much like you do with Pact, you can put into your build, you basically define in Avro, in a schema definition language, your Kafka messages. You store it in a repository, much like you do, Docker Hub or something, and you can use this Maven plugin to verify you're adhering to the schema, or if you're changing the schema, what the impact would be. So these things are totally possible, both from an API level and a schema level, to weave into your build pipeline now. The question we have to ask as technical leaders, as architects, is it worth the cost? Yeah, is it worth the cost? And I mean the cost not just necessarily in terms of money, but in terms of my time, my team's time, these things. And for me, everything as an architect is about trade-offs. Everything we do is about trade-offs, and it's identifying what we're trading off. That's the hard thing. My anecdotal experience is with things like consumer-driven contracts and other contract stuff, we're trading off trust and communication against cost of implementation. Now, I've worked in some startups, and we actually found that doing contracts was not worth it. And this is, again, massively anecdotal, yeah? Just in this 1 or 2 examples I'm talking about. We actually found that, yes, it did pick up in the build. We built Pact into our build, and when we changed the contract, it was a cue for a conversation, how we broke the contract. So I walked to the next desk and go, hey, Bob, hey, Jane, I've broken the contract, and we would talk about why I'd broken it and so forth. In the end, we realized that it was just quicker to have that conversation. If I knew I was going to be breaking something, I'd have the conversation rather than spending all this time maintaining these schema, these JSON definitions of our contracts, yeah? And we had end-to-end critical path tests that caught problems largely when we made mistakes and forgot to chat to the other team, yeah? What I would say, enterprises, though, where, and this is a massive generalization, but enterprises where trust and communication tends to be suboptimal, shall we say, sometimes, and it's just the way the enterprises are built. They're working with bigger systems. You have departments, you have silos. It's a reality. There, I find the cost of doing these kind of contract things in a build pipeline is actually often worth it, because it just captures stuff, and it's not that you should point the finger, but it forces you to identify where in the pipeline things are going wrong, who has broken these kind of things, yeah. One caveat I would mention around serverless stuff is we're seeing a lot of talk around orchestration of serverless versus choreography. So orchestration is kind of being very descriptive in what you've got. Think of it as BPM, business process modeling, that kind of stuff, like BPEL. There is serverless versions of BPEL coming up now. AWS Step Functions, Netflix Conductor, Apache NiFi. There's all these different tools coming out now. And choreography is much more loosely formed. Things make decisions and kind of just choreograph, like a ballet kind of thing, as they go through the actual process of delivering business value. Now, orchestration, because I've got all my serverless stuff going on, and I've got like an orchestration language detailing how these things work, I often assert properties on that language. I don't assert properties necessarily on individual components within the system. They're just too small, yeah? And therefore, don't think the cost is worth it with these kind of contracts. When I'm doing choreography, often the behavior is more important between microservices, between the functions. And therefore, contracts can be worth it in this case, in my experience. So that is, take this with a pinch of salt. Anyone who stands on the stage is sharing their successes, their failures, and there is always context involved. I've learned as a consultant, I say it depends a heck of a lot, and that's because when I say it depends, I actually mean I don't know your context. Yeah, what's your organization, what's your skill set, what's your team, all these kind of things. So bear these things in mind. This is just me sharing some of my learnings with you. Your mileage may vary. Testing what we call non-functional requirements in the build pipeline. And I don't like non-functional requirements. I've seen many systems that were not functional due to non-functional requirements. I prefer things like system quality attributes, something like that. Take your pick. But things like architectural quality, I regularly use SonarQube and Code Climate to determine are we, you can do things like cyclomatic complexity and various different metrics of cohesion, all these kind of things. Put it in your pipeline, run it continually, all good stuff. I'm going to dump a load of books up here as well. I love reading, long commute in the UK. Performance and load testing, I'd highly recommend doing performance and load testing on your whole service, whole application, but also on your individual services. Get a baseline. I've actually worked on one system where we were doing code modifications to this one service, and it hit a critical sort of point where we were degrading the performance. We didn't realize it, and we degraded the performance, and we didn't have any performance tests in there, and we pushed it to production, and the whole thing just collapsed, yeah? So we rolled back, we fixed it, we identified what was going on, but then we used, at the time it was JMeter and Jenkins, and we ran happy path load tests on every build. And you could just see the trend, oh, that thing's getting slower. And it was our thing, it was like an XML parsing garbage collection issue. Once it hit a critical path, the performance just went tanked. But put it in your build pipeline. Yeah, these, Gatling I use a lot. Locust is like a Python thing, I think. Bees with machine guns is all different times, all different kind of things you can use to do performance testing in your pipeline. Security testing. This is take my cues from Sam Newen here a little bit, but it's becoming a bit of a bugbear of mine, and particularly things like the Equifax thing are making me really think about this stuff as well. If you haven't heard of OWASP, please go and have a look at OWASP. They're an open source kind of consortium that talks about security. They've got a few awesome tools you can put in your build pipeline. One is a language neutral dependency check. So it can basically, it communicates out. I run it in Maven, for example, and it communicates out to an OWASP server and says, oh, you're bringing in all these different dependencies, all these libraries at this version. Is there any known CVEs? Is there any known critical vulnerabilities? And like some of the old logging libraries have got massive vulnerabilities, so you want to make sure not only your dependencies are free of those, but your transitive dependencies are free of those issues as well. And tools like this, if anyone's familiar with the Maven Enforcer plugin, it's kind of like that as well. But that one is language agnostic. It works for Ruby, it works for Python. And think about these things. If you're building containers, think about like Docker Bench or Claire to do these things. Threat Modeling is a great book for understanding about security in general. So I do get some pushback as a consultant where I sort of start talking about performance, about architectural quality, about security. And people often say to me, well, not often, some people I should say to me, we're agile here. Yeah, we delay things to the last responsible moment. And I like that, and I like the last responsible moment thing. I don't like it with NFRs, but I like it with the last responsible moment. It basically says, we're making decisions often at the start of the project. We don't know too much. So actually, let's defer that decision until we know more stuff. We're better grounded at making the decision. And if we defer it just before the last responsible moment, we've got the most knowledge, whereas if we don't make a decision then, it would be irresponsible, or one is made for us by our inaction. Yeah. And I get it, yeah. And again, when I'm building functionality, like this totally makes sense. We don't know very much. We learn, make decision. But the newsflash in regards to system quality attributes is sometimes the last responsible moment is actually up front, I think, yeah. And I've certainly, been guilty of doing things bad in this space, yeah. Nothing in production too much, which is good. But this is really important, yeah, and modern architectures don't make this easier. I had one project where my team and I were called in, and we had to retrofit security into like 20 microservices. Yeah, it would have been hard enough in one monolith. We couldn't do it in 20 microservices. They'd all been designed subtly different as well, which was a nightmare. So it leads to this kind of thing, which impacts onto the pipeline. I can fix it right, or I can fix it fast. And often people like to optimize for fixing it fast, and it never gets fixed ultimately, yeah? And your pipeline degrades, and it's that whole thing with broken windows. Yeah, bad things happen. So off my soapbox for a little bit, but it's really important to think about system quality attributes, security in particular, but also things like performance and maintainability. Deploying, I'm only going to cover a couple of things with deploying. I think modern architectures do demand independent deploy and release. So things like feature flags, and Sam's done an awesome talk recently, which you can check out on YouTube around these things. But really, you want to be continually pushing stuff into production and turning it on and off on demand, in my experience. I really like that. It's not always easy in microservices. You have to make sure you enable functionality up the stack. So you turn it on at the very low levels and it cascades up. And you must disable functionality at the beginning of the ingress point, for example. So I've made a few mistakes where I didn't do that, and we confused customers with various sort of feature flags. But Sam goes into much more detail about that stuff. Also popular with modern architectures, with modern platforms like Kubernetes, ECS, and things like that, is the notion of shadow traffic, so canarying things, or shadow trafficking. You often sort of copy a portion of live traffic, send it down your new test system, and the results you don't show to the end user, you capture and you analyze them. So Twitter have got a tool for doing this called Diffie, which I haven't used it like at a production site yet, but it never kind of fitted exactly what we were doing. But we've taken the concepts before and often done, like, say, even HTML captures of different requests. Requests going down the current stack, you shadow some traffic off to the new stack, and you take like a picture of the headless browser of what the traffic, what the response looks like, for example. So these things, I think, go hand in hand with modern architectures, with continuous delivery. A point I want to make here is now that we're dealing with complex systems, distributed systems, we cannot always assert all of the properties in the pipeline. Sometimes we have to use things like observability. Sometimes we have to use things like, canarying stuff or shadowing stuff and just seeing what happens. It's just too complex a system. Or our time and money is better spent observing than it is asserting in the pipeline. Bit controversial, massively context dependent, just throwing it out there, yeah? Now, I'm super interested, as well as I'm doing serverless stuff, I'm looking at things like service meshes, which are super interesting. I've got a whole talk online. You can find that. I did it a couple of weeks ago. Things like Istio, if you're in Kubernetes space, Linkerd is JVM space. But you can basically have multiple things running in production, multiple microservices running in production, and you can route traffic accordingly based on headers or devices. It gives you more options of doing things like canarying and like shadow traffic. Taken to the nth degree, serverless allows even more cool stuff, yeah? Serverless, because I'm only charged when I'm dealing with a request, I can have multiple production environments at any given time, as long as I can manage them, or as long as my team and I can manage them. But we're not being charged to spin up this thing. It only charges us when we are dealing with a request. So I can have multiple production, sort of environments, and I can use something like Route 53, like a DNS thing, to effectively weight my traffic, 10% going up to this production environment. You've got to be a bit careful with the back end if there's data involved, obviously. But serverless gives you whole new kind of tools to play with in this kind of canarying space. Hopefully sort of perfect time there. So wrapping up some of these things, I gave this brain dump, and I'll share the slide deck later so you can have a look at some of these things. But some of the points I'm trying to make, and I hope this comes across. If not, please do let me know. It's the first time I've given this talk at a big conference, and I'd love your feedback, genuinely, as long as it's constructive, please. I love your feedback. But the points I'm trying to make with some of these things, we as technical leaders have got to recognize what architecture is most appropriate, and then work with our teams to deliver those things. But we've also got to recognize how continuous delivery fits into this. And for me, so with monoliths, its cohesion and coupling is enforced at the kind of module level, or at least it should be. And CD focuses on end-to-end functionality. Once I've got a pipeline working, I'm kind of good to go in a monolith, yeah? And therefore, I, as a consultant, often recommend I sort of provide goals, business goals, and best practice examples. We are working with a Java monolith. This is the best way to do monitoring. This is the best way to do logging, that kind of thing. When I'm looking at things like SOA, its cohesion and coupling are typically enforced at the service layer level or the transport level, like an ESB or an MQ, that kind of thing. And therefore, CD often focuses on service integrity. Is my service working right? And therefore, I typically provide objectives and standards. It's the kind of classic enterprise space, yeah? Things like microservices, we're moving it more from the service level to the actual API level. And that can be an actual REST API, or it can be something like a message API, a message schema. CD focuses typically on service interaction, behavior, and state, but fundamentally the interaction. And therefore, you kind of have to dial it back a little bit. As a technical leader, this is where it gets tricky. We have to provide more principles and guidelines. If you've got a polyglot stack on, you can't say this is the best practice for doing Ruby, best practice for doing Java. You provide, in my experience, I found providing principles and guidelines is much more effective for doing these things. I've got a whole talk about microservices that goes into this in more detail, actually, and microservices, the people and impact, people and organizational impact. But it's subtly different from the kind of the things you're going down through there. With serverless, I think coupling and cohesion should be enforced at the kind of the ingress point, the API gateway, say, and CD, in my moment, at the moment, and it's still a massively emerging space, focuses on service, output, and state. I'm not so worried about individual functions. Often they're more analogous to my methods in a Java monolith, but I'm interested in the kind of the behavior and the state, kind of what happens when I trigger an event and something happens. And therefore, it's even more loose. It's providing things like values. What are we as a business optimizing for? Rules of engagement, like don't spend silly money by spinning up massive databases, or don't have a service that runs, because you're charged on the gigabyte millisecond, or gigabyte microsecond. So the rules of engagement around those things are super valuable, yeah. But this, you notice it kind of gets harder in terms of leadership as we go down through. And this is what, coming back to my core messages, I think the role of architect is fundamentally changing. Has anyone seen the Laughable framework? It's basically like, I'm not going to name some of the names. This is a joke framework around scaling agile, yeah? And it's got, you go planning, then you go strolling, and you have half-met ideas and so forth. It's well worth a Google and a look. But one thing I was kind of disappointed about is in the framework, just here actually, you can see the architect. This is the team responsible for your scaled agile in your enterprise. The architect there is in the ivory tower, yeah? And going into it in more detail, it basically says, the traditional notion of architect is designing things up front, mapping out plans, and there is definitely some element of that in an architect's role these days. Architect is a very wide-ranging job title, I would say. But I do really think you have to, as an architect, if you're trying to use these modern paradigms like microservices and serverless, you have to get your hands dirty. You have to code, you have to work on the pipeline to sort of encode your learnings, your beliefs, your requirements into the pipeline and assert these properties continually in the pipeline, yeah? And that kind of comes back to what we started with by saying we are definitely moving from complicated systems to complex adaptive systems. They are distributed systems. And for me, it's like been a massive level up. It's over the last 5 years, as I've worked more with microservices and serverless, it's been a journey where I've had to learn a lot of new things, yeah? The 8 fallacies of distributed computing, all these things. My role as an architect has become a lot more about technical leadership. And again, hat tip, Pat Kuar, Simon Brown have been massively influential in my career. But I had to recognize often as a consultant where I am, situational awareness, what's our goals, what's the organization like, what's our current skill set like, and then influence people accordingly. And then definitely one thing I found for baking some of this stuff in is putting it into a continuous delivery pipeline. Yeah? This is a way of encoding your knowledge and continually testing it. Critically from a functional point of view, but also from a non-functional point of view as well. So that's it. I would say I'm doing like a book signing, book giveaway thing tonight at 5:45 at the O'Reilly booth. So if you want a free copy while they last of that book, you can come along and find me. We're doing a workshop on Wednesday morning around microservice testing as well, a very small focused workshop. So welcome to come along and join me. But I will say thanks for your time and attention. Very much appreciated.